Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today, spatial array 2, Leetcode 3152. In this problem, we are given an array of integers, nums, and a list of queries where each query I denotes the index in the array from I to 2i, and we have to check if the given subarray in the numbers between those indices is spatial or not. An array is considered spatial if every pair of its adjacent elements contains two numbers with different parity. Parity here refers to the property where a number is odd or even. If one number is odd, then the next number should be even. And similarly, if one number is even, the next number should be odd. So if all the adjacent elements in the subarray follow this kind of an alternating parity, then that subarray is spatial. In example 1, for the given query, the indices are 0 and 4, and we can see that the first number is odd, then the next number is even, then the next number is again odd, then we see even number, and then we again see the even number. So we can see that there are two elements within the subarray 0, 4 where the parity doesn't change, and because of this we will return false for this query. Similarly, in example 2, we are given two queries. So first query is between 0, 2, and we can see that the first number is even, and then the next number is odd, and again the number is odd, and finally the last number is even. First query is between 0 and 2. So we can see that there are two adjacent numbers in this subarray which are with odd parity, and because of this we will return false for this query. And then for the second query, the indices are 2, 3, and here we can see that the numbers 1 and 6 are with odd and even parity. So because of this, we will return true because this subarray is indeed special. Now in terms of solution, one of the naive approach can be that we can iterate through each query, and for each query, we will examine the subarray from index from I to 2i to ensure that all adjacent elements have different parity, and then we will store the results in a Boolean answer array. However, the time complexity of this approach will be O of m into A, where m is the number of queries and A is the average length of each subarray. In the worst case, A can be equal to n, where n is the length of the entire array. And in terms of space complexity, it will be O of m to store and return the answer from m queries. And now the question is, do we really need to check the parity of adjacent elements for each query again and again? Can we somehow pre-process the array to reduce the query time from O of n to something lower? And the answer is yes. If you remember, we have seen similar problems in past as well, such as XOR queries of a subarray. In that problem, we needed to repeatedly XOR elements based on the indices provided in the queries, and there we use the prefix sum technique. Given such queries in this problem as well, that technique can be useful here as well. So how can we generate prefix sum or pre-processed array for this problem? For that, let's focus what is the issue here. It is when the parity of adjacent elements don't change. For example, if the parity was even and the next element has parity even, then that is a problem. Similarly, if the parity of the element is odd and the next element again has a parity odd, then that is a problem, because then the array cannot be marked as spatial. So how about we generate the prefix sum kind of an array starting with value 0 for the first index. So for example, for value 3 it will be 0, and then we can iterate through each remaining element in the array and compare the parities of the adjacent elements. So if the parity of the current element is same as that of previous element, then we will increment the value of prefix sum or prefix count by 1. Otherwise, if the parity changes, then prefix sum value or the prefix count value remains the same. For current element 4, which is even, the previous element 3, which was odd, the parity changes. So prefix sum or prefix count value stays 0. Then the next element is 1, which is odd, and the previous element 4 was even, so parity again changes. So prefix count value says 0 again. Then the next element is 2, which is even, and the previous element 1 was odd, so parity again changes, so the value stays 0. And finally, the last element is 6, which is even, and the previous element 2 was also even, so prefix count increases by 1. And now, as we are done with all the elements in a nums array, we have calculated the prefix sums array, and we can start using it to process the queries. Now for any query indices, if the prefix sum or prefix count value at the start index and the end index are same, then for that particular range, there exists no pair where parity is same. But if the value differs, then it indicates that there is at least one pair with the same parity within the range, hence subarray is not special. For example, for query 1 and 3, the prefix count at both indices is same, indicating we couldn't find any pair of adjacent elements with same parity. So that means this is a special subarray. So in this case, we will return true as our answer. But for query 0 and 4, the prefix count is not same and the difference between them is 1. So that means there is at least one adjacent pair where the parity was same. And because of this, we will return false as our answer for this query. And in the end, we will return this Boolean array of the size of queries as our answer. Now let's jump into the code part. First, let's initialize some variables. Let n be the length of the nums array, and let's also create prefix sum array of size n. Prefix sum or prefix count for 0th value in the nums array will be 0. Let's also initialize the variable j to keep track of number of adjacent elements with the same parity. Now we can start iterating on the nums array starting from the second element at index 1 to the end to calculate prefix sum for the remaining elements. For that, we check if the parity of the current element is same as that of previous element. How can we do that? If after dividing the current number by 2 and the previous number by 2, the remainder is same, then that means the numbers have the same parity. So in that case, we will increment j by 1 and update the value in the prefix sum for the current element with this updated value of j. And once we have calculated the prefix sum array, we will start processing the queries. So for that, first let's create the answer array of the length queries and iterate through all the queries. Let's extract start and from indices or from and to indices in the nums array for the current query at 0th and first index. And now we compare the prefix sum value at from and to index. If it is same, then the value will be true. Otherwise, the subarray is not special, so value will be false. And once we have processed all the queries, we will return answer. Now let's submit this code. Cool. In terms of time complexity, now it is O of n plus m, where n is the length of the nums array and m is the length of queries array. And the reason for this is first we are pre-processing the nums array, which takes O of n time. And then we are going through each of the queries. We are processing each query takes O of 1 time. So for m queries, it will be O of m, and hence overall time complexity is O of n plus m. And in terms of space complexity also, it will be O of n plus m, because we are creating this prefix sum array which takes O of n space, and then we are generating this answers array which takes O of m space. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.